Hello everyone, my name is Daniela Ramirez, and through this video I will be presenting my science project for the class EDCI 3333. Basically, my hypothesis is if vinegar is independent variable with the highest acidic pH, then the pennies submerged in this liquid will turn out to be the cleanest. So what I'm basically trying to prove is which of substances from 5 different that I'm using will clean the rust of a penny. My 3 research questions are: what causes penny to rust? Well, pennies are composed, first of all, 95% of the pennies are copper, and that when they're exposed to the oxygen in the air we breathe, it oxidizes, causing to form a green layer over the penny. Now, my second research question is, based on the pH level, or otherwise known as the acidity, which liquid will reduce or completely clean the rust formed on the pennies? Basically, we must think of how acid a substance is by recalling if their taste is sour. Most of the times, sour foods are acidic due to their ion concentration. So, of course, not all substances tested are consumable. Therefore, we must consider the odor of the substances being tested. Now, the substances I'm testing are white vinegar, Coca-Cola drink, toothpaste, peroxide, and baking soda. So my independent variable are all the 5 substances are being used. My dependent variable is the changes we'll see in the rusted pennies. My control variables are the rusted penny, a non-rusted penny, like just a clean penny, and the time lapse that the pennies will be tested. So we'll be testing the pennies for 72 hours, making observations every 8 hours. As you can see, I have already labeled the cups with the names of the liquids I will use to clean the rusted pennies. I have already put them in decreasing order from least to most, obviously, based on their acidic pH level, starting with tomato, baking soda, toothpaste, peroxide, Coca-Cola, and white vinegar. Next, according to our procedures, I will put a couple of cotton swabs into each cup so that I can later put the pennies on top. So I'm going to add about 2 to each cup. Now that I have added 2 cotton rounds to each cup, I will go ahead and place 1 penny into each of the cups. So as you can see here, I have all the oxidized pennies, and this is just a regular penny to see the difference between a rusted penny and a regular penny. And we will check every 8 hours for an overall of 72 hours. I have finished placing 1 rusted penny into each of the cups for our experiment. And aside, I have left our control variables, which is a rusted penny and a regular penny, for us to compare at the end to see which liquid cleans the pennies the most. I will now add 5 milliliters of either Coca-Cola, toothpaste, peroxide water, solution of baking soda with water, and tomato sauce to each of the cups corresponding to their label. So for this one right here with the toothpaste, I will add 5 millimeters of toothpaste on top of the penny. For the baking soda one, I will prepare a solution of 1/4 teaspoon with 5 millimeters of water to add into that. And for the Coca-Cola, again, I will also measure 5 millimeters to put on top of the pennies. And as you can see, we already have the pennies inside with the cotton swabs. Now I will prepare the solution I will put inside the penny that we'll be testing with the baking soda. So as I mentioned earlier, I'm going to use 5 millimeters of water with 1/4 teaspoon. And I'm going to mix it together until well combined to add on top of my penny. That should be enough. Now you can see there, I will pour it on top of the penny, and now our cotton rounds will serve to have the penny submerged at all times. 72 hours have passed already, and I will now conclude with my experiment. As you can see, we still have baking soda, the toothpaste, peroxide, tomato sauce, the Coca-Cola, and the white vinegar. I have removed all of the pennies from the cups, as you can see. They still have a little bit of residue because I didn't want to scrub off to make any additional changes to what I really wanted to test out. So let's have into consideration that the two of the pennies that were tested with colloids, which were the toothpaste and the tomato sauce, were only exposed to the specific liquid over it and not on the bottom part, whereas the other pennies were at first only the cotton round was the one damped, so it might have done a bigger effect on the bottom side of the penny, and later we added more of the liquid to make it submerged and see if there was any changes. We still see a little bit of the green layer, which is the rust of the penny. Now when we face it down, which was the part that was exposed the most to the liquid because it was sitting on top of the cotton round, we see that the liquid corroded the coin. There are unexpected stains, but from the top, throughout my observations, I saw that the damped cotton rounds were actually cleaning from the rounds of the penny. So we have that. Our second penny, which was the one that was submerged in Coca-Cola. Again, this is the part that was facing on top. It was like this. So the bottom part, which was the one facing the cotton rounds, again, we see unexpected results. The coin is stained differently. So we have that. And again, a little bit of the same that happened with the first penny, that the cotton rounds that were the most damped were the ones that cleaned from the outside inwards of the penny. Our third penny is the one submerged in tomato sauce. We still have a little bit of residue. I didn't want to scrub it off to prevent any of the rust coming off. We still see it rusty, and from the back part is just cotton residue that we still have. I'm guessing that some of the tomato sauce went down the coin. Let's remember that it was only exposed on the top because the colloid wasn't absorbed by the cotton round. Our fourth coin is the one that was inside peroxide with a pH level of 4.5. This is the top and this is the bottom. Throughout the observations, I saw it bubbling. Maybe we can still see some of the residue. There's still a green layer, but in comparison to the others, it's not that much. Now, our fifth coin, it was the one that was under the toothpaste. We still have residue, as well as the one in the tomato sauce. Again, I want to scrub it off to prevent any of the rust to come off by me scrubbing it off. On the bottom, again, we have a little bit of cotton residue. But here's this one. It's very dull. And then we have our last penny, which was the one submerged in baking soda. So this is the bottom part, the part that was sitting on the cotton round. We see that it formed a little bit of crystals. When I touch it, I can feel like bumps of small crystals. Instead of cleaning it, I think that it made more of that. It's also white, which is not cotton. And then from the back part, we do have a little bit of cotton residue, but that's a part.
Here are my tested pennies in comparison with my two variables, which is the rusted penny on the top left, and on the top right I have my clean penny. Although the penny submerged in Coca-Cola looks more of the color like it in the camera, in real person, the one submerged in peroxide is the one that looks in real person the less oxidized. So it's just the matter of the lighting, I guess, and the cell phone camera. But in real life, the one in peroxide seems to be the most clean.